Okay, this is Chapter 1, Section 1, Interval Notation and Set Notation. We're going to learn about interval notation and what is called set builder or set notation. Before we start, we need to talk about sets and subsets. A set of things is a collection of objects. That should be pretty easy, but something you may not be aware of. Let me pick my red pen here and shrink it just a little bit. There we go. Is you may not know about the braces. You can use braces to represent a set by listing its members or elements. For instance, the set 1, 2, and 3, a set with 3 numbers in it. The brace is like a parenthesis, but it's the fancy parenthesis. Kind of looks like that. And if you wanted to say, well, I have a set of 1, 2, and 3, then I open my set with the brace. I put a 1, I put a 2, put a 3, then I close it. And that's the set of numbers that I have. I've got a 1, I got a 2, I got a 3. And that's it. Okay. A set with no elements is the empty set or null set. Can be represented by empty braces. So you could just say there's nothing in there. Or you can do the O/y thing. That means no solution, no answer, empty set. Okay. Many other sets are also described in words, such as the set of all real numbers and the set of all odd whole numbers. We can write them as it is here. So there's the brace, then an X, then a line that's vertical. Then X is a whole number and X is odd. And you close your brace. And the way we read that is the set of all real numbers X. So that's the first open brace X is the set of all real numbers. The line is basically the such that, and then that X is a whole number and X is odd. You've got both of them written in there. If all the members of a set A are also members of set B, then it is a subset. Okay? So the set of natural numbers 1, 2, 3, 4 is a subset of the set of real numbers. And let's look at the subsets of real numbers. The further inside the set you are, okay, the outer piece includes the things inside of it, but the ones inside don't include what is outside. And these are what we call the different levels of numbers. Okay, the insidemost are natural numbers, symbolized by an N, and the natural numbers are the things that naturally occur in nature, things that you can see, like there is one tree and it has 20 leaves, and things like that. When you can't see anything, it's not there, so you don't count it. So natural numbers start at 1. Oop, that's an eraser. Start at 1 and go up. Then we go out to the next level, the whole numbers. And what is added in with that group, that set of numbers, you have all of the natural numbers inside there, 1 counting up to infinity. And then the whole numbers, which is symbolized by W, adds in 0. Adds in a 0. So when you talk about whole numbers, it's 0, 1, 2, 3, 4, all the way to infinity. Natural numbers is just starting at 1. And then we get into integers. Integers, represented by a Z, integers adds in the negatives. Adds in the negative numbers. So now we're adding -1, -2, -3, -4, and so on and so forth towards negative infinity. Then going out bigger, the rational numbers. Rational numbers is symbolized by a Q. That is adding in fractions and decimals, so parts of a number. So we've got fractions and decimals, but they're specific. That's fractions and decimals that stop or repeat forever. Repeat the same thing forever and ever and ever. So things like 0.5 stops. 1/2, same thing as 0.5, they stop. 1/8, 0.125, even though it's 3 decimal places, it stops. So that is a rational number. Even things like 1/3 or 0.3 that repeats forever. It's got the little bar on top of it, means repeating. Those are rational numbers. Irrational numbers are numbers that are fractions or decimals, but they don't stop and they don't repeat. So irrational numbers are things like pi, or the square root of 2, square root of 3, or the square root of anything that doesn't have a perfect square. And then we get out to the big R, the real numbers. And it's weird that we have to say the word real because, well, maybe not to most. Some of you think that math is a very abstract thing and you don't like it, but that's okay. It's still real. But we have to make the distinction because in math there is a non-real number. There is something called the imaginary number. This is a number that we have to deal with because it comes up in an answer in math, but it's a thing that's impossible. Okay, and we'll get to that later in Algebra 2 when we start to talk about complex numbers and start solving quadratic equations. This -1 will pop up and we'll have to deal with it, but we'll deal with it then. Okay, let's talk about interval notation. Interval notation is the first kind we're going to talk about. It's just a different way to write your answer. Sometimes it's a little more concise way to write your answer. It's a little bit shorter. And we'll see some examples here. There's two kinds. There's bounded and there's unbounded. Bounded and unbounded comes from the word boundary. Okay? If it's bounded, it has boundaries. It has a start and it has a stop. It has a limit that it can be. It will have an end point. Okay? And we symbolize that in different ways depending upon how we interact with the end point. Okay? If there is a fence around your property and it is bounded, you can touch that fence most of the time. Like if it's a wood fence, it'd be nice and fine. You could touch the fence, lean on it, climb over it, all that kind of stuff. So you could be part of that fence. You can touch it. If you had an electrified fence, you'd be locked inside the boundary, but you wouldn't be able to touch the fence part, the part that binds you to that place. And that would be a different symbol in math if you can use that point or you can't use that point. So let's look at the chart here. We've got the inequalities listed, and they're just using letters to represent where numbers will eventually go. So anything can go in for A, anything can go in for B. If we have A less than or equal to X, less than or equal to B, interval notation is going to look like open bracket A, comma, B, close bracket. And here's how that goes. Okay, your starting point is at A, so that's the first letter. Your end point is at B, that's the second letter. They're separated by a comma. That comma represents all the things in between them. Now, the bracket versus the parenthesis. This was a thing that I had to really think about and come up with a way to remember it. So, the way I remember it is if there is a straight line for an equal sign, then you get a straight line bracket instead of a curved parenthesis. So equal sign, straight line. If it can be the thing and touch it, it gets the bracket. If it can't be the thing, then it gets the open parenthesis. And the other way I can remember that is whenever you do the open circle, half of an open circle is basically a parenthesis. So can't touch it, gets half the circle. So that's what we're doing here on the notation. So you put the starting point, if it can touch it, bracket. If it can't, parenthesis. Then the end point, and if you can touch it, bracket. If you can't, parenthesis. And you can even have mix and match. Like you might be able to touch the starting point, but not the end point. You might be able to touch the end point, but not the start point. But all of those are bounded intervals. The length of any bounded interval is the distance between its points. Okay, a distance between its endpoints. So you're going to subtract those, take the end, subtract the beginning. That is its length. Any bounded interval has a finite length. It has a stopping point. Any interval that doesn't have a finite length, anything that goes on forever, is known as an unbounded or an infinite interval. those are symbolized a little bit different. Okay, here notice we have A and B. We've got two numbers, a start and a finish, and the X is the kind of the comma in the middle. So that's the part we color in on the graphs over there on the right.